In physics, it's very common to need some kind of approximation just to solve the problem, not just to make the problem easier, but just to make the problem solvable at all. One of these approximations you've already seen, the small angle approximation. And here's another one, which is called the binomial approximation. It appears all over the place. What we're going to show is that so the binomial approximation, one application of it is taking square roots. Suppose I want to know the square root of 1 plus a tiny number. For example, I would like to know the square root of 1.1. Epsilon is the tiny remainder of 0.1. You can check that if you put it in your calculator, the square root of 1.1 is about 1.05. So that's interesting. It looks like you just take 1 plus half the remainder. Is this true? It's kind of just a guess based on one number, but let's prove it in general. I'll prove it by squaring both sides of the equation. So if I square both sides, I'll have 1 plus epsilon over 2 squared. And that is equal to 1. The cross term gives me epsilon. And then there's an epsilon squared over 4 term. But remember that epsilon's tiny. So when you square it, you get an even tinier number. And so indeed, this is approximately just 1 plus epsilon. And that proves that this is a valid approximation. So this lets you calculate square roots of things very close to 1. But more than that, suppose I want to know the square root of like a squared plus b squared. For example, I want to know the square root of 26, which is 5 squared plus 1 squared. Here's an approximation scheme to do it. So first, I need to write it in the form of 1 plus epsilon. To do that, I'll factor out a from the square root. And then I'll have 1 plus b over a squared. I'm assuming a is much larger than b, so that I have a square root of 1 plus epsilon. And then I can use the approximation. This is a times approximately this is 1 plus a half b over a squared. In other words, multiplying it back in, I have a plus a half b squared over a. So in this way, we can take the square root of any the sum of two perfect squares as long as one of them is much bigger than the other. That's one use of this. Now, in fact, this square root version of the approximation is just one variation. Suppose I have any power, 1 plus epsilon. What I've just shown here is that 1 plus epsilon to the 1/2 power, means square root, is approximately 1 plus a half epsilon. But in fact, it works for any power, not only a half. 1 plus epsilon to any power. It could be the power of 3. It could be minus 4/3. Whatever p is, it's approximately 1 plus p times epsilon. Let me give an example. Suppose I have 1 over 1 plus x, and this is quantity, I don't know, cubed. And I'd like to approximate that. This could be some kind of force that depends on x, and to solve the problem, I have to make an approximation. So first I rewrite it. This is 1 plus x to the minus 3 power. And now I use the approximation scheme. As long as x is small compared to 1, then this is just 1 minus 3x. You go from a sort of complicated function to one that's just linear, much simpler. So we'll use this over and over when we have complicated type forces or energy expressions that we need to approximate to get a solution.